All right. So I was just making some notes on a notepad, like a physical one, and let's give it a shot at something. So I think we can keep that as well as the direction. Let's see. Yeah. Okay. Let me explain what I came up with, and then I will see if I can actually change the code somewhere. All right, so let's take a look at the instructions here, right? So we have, just as a quick recap, every time this uh, array here has a value, it means that the robot needs to move that amount of times, and then it will always be walking down this pattern. So up, right, down, left, up, right, down, left, and that's the cycle that the robot will do. The robot changes direction whenever the movements change. So it moved upward 4 times and then rotated to the right, and then moved 4 times to the right, rotated 3 down, 2 left, and then 2 up again because it's turning every time it finishes the movement. Basically, that's the idea. What we want to know is whether the robot has crossed paths at least once, like in this case. So you can see we have the same instructions, and then we have the robot crossing the same path twice because it visited 4, 3. So 1, 2, 3, 4 in X, and then 3 in Y. 1, 2, 3 here. This was visited twice. Therefore, the answer should be true, right? Okay, so having said that, what I want to show here, let's actually keep this image so we are a little bit more in context. So what I'm planning to kind of implement here is something like so. Oh, Mike was okay. So let's say I will either do it like on the x-axis or the y-axis, but let's keep it on the x-axis and say we have 1, 2, 3, 4, and 5, let's say, right? So let's say that this was x values, right? So based on the movement of this example here, the robot in here, we will have like, let's call them y values. And then we will say these can be like arrays. All right, I probably can skip this part, but it's okay. So for the movements that we have here, we have that on the X, we visited in order the 0, and then 1, 2, 3, and 4, right? Because that's what we did. And then on the for X1, we visited based on the order that we have here, we visited just 4, if that makes sense. So 1 on the X and then 4 on the Y. And then 2, we visited 4. But then the next time we visited was when we went back here. So we went here. So next time will be 1, 2, and 3, right? 1, 2, and 3. And then for the next x value here, 3, we visited first 1, and then we visited 3, right? Because it was 1, and then it went around and came back here. And then 4, we visited first in 4, then 3, then 2, then 1, right? We went 4, and then 3, 2, 1, correct? And then finally 5, we visited at 3 once. Hopefully this makes sense. If not, I think if you go through the path and try to fill in the same values, you probably, not probably, but you will get at the same conclusion, that these were the points in y for each value of x, if that makes sense. All right. Wait, I have 4. Oh wait, 4, 3, 2, 1, and then 3 again, because we made the whole trip around again, right? So we visited this point when we were coming down, and then when we went this way. So that's what this is all about. And this was actually the point of this exercise, making it filling the array values this way, right? So here we don't have any recurring values, neither here or here, but we do for the 4th, or for the point 4 in x, where we have the 3 here and then the 3 over here. So I wonder if this could be like a good structure to keep track of where in the x kind of array of values we were at, based on the y position, if that makes sense at all. So if I could keep like a map of each x value that I can then fill in with an array of values for y, maybe I can determine whether we visited more than once the same coordinate. The original solution was to just keep track of every single point as an xy string value here, like so, and then determine if any of those was repeated at all. So that's what we're doing here, basically, just making sure that if we took out all the repetitive, or the repeated values, then the length of the actual points would be the same as the original one. That was the original solution. I wonder though if something like this could help us determine it more easily, because the problem right now that we have is not that the solution doesn't work, because it does. So if I test this, you will see that for some particular values we can actually run it, and if these tests are okay, so it kind of works, but it doesn't when we attempt for more values. And one important thing here is that there's a constraint that we will have at least 3 movements, so an array of 3 values here, and that the length of this array will be at maximum 100 instructions per array, but also that we can have up to 10,000 movements in like a grid. So wondering if something like this structure could help. Let me see if I can actually code it, and I'll keep recording, and we'll see if we can actually make it happen. All right, so we know that we have this direction, and we know when it changes because of this, I think. So what I can do, oh, and I added this part, which, yeah, this wasn't part of the original solution or the latest solution I pushed. Yeah, it was more like this. Let me see. So here we are. Number of moves is going to be the A. We're walking down the A array, which is going to be something like this. And then when we are facing a new direction, okay, instead of pushing this new value here, what I can do is, let's see, let's do xvals or something. There's going to be this kind of map here where xvals at x let's do if we have a value already, if we have a value, then just push it, push the y value, and if not, then this will be a new array with the y value, I think. And yeah, let's try with that and see what happens. I'm going to, yeah, I have already kind of, I already created a backup of that, so let's just keep it more simple. And let's do a simple log of xvals and see what happens. What I need to do though is to not print all of these, maybe, so I don't get all confused. And let's keep oh, let's keep the tests real simple. So for this test here, it should return true, right? But we're not testing that just yet. It doesn't really matter. Let's test this, and we should see something similar to this. Let me close the window real quick. All right, so we have 1, 2, 3, 4. Okay, except for a 0. And then we have 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3 again, which I guess it's going to be correct. Let's see. X3. Oh yeah, the first one was 4. And then 1 and then 3. Yeah, that's right. So I missed one actually. And then 4, 3, 2, 1, 3, 4, 3, 2, 1, 3, and then 3 again. Okay, cool. The only value I am missing though is 0, which I'm not certain if we actually need it, because yeah, there could be a point where the robot walks into the 0, 0, I guess. So let's try. We're not gonna need path anymore. Let's try with okay, let's try 0 is going to be the array is 0, right? X0, Y0. Try that. And then we have it. So we just initialized this because I think we do need it. We eventually want to know also if we went back to 0, 0, I think. All right. So now it's going to be a matter of, man, this is probably going to be still a very large structure, just like our array of strings. But this is just another way to kind of store the information. So let's see. Is there anything in here that I could leverage to say, no, it's basically just know whether we actually went more than once into that. So let's keep a similar approach to the one we had before. And let's do object dot so we don't need to know which of them was, so we can go through the values, right? We don't need the keys at all, I think. For xvals, so at this point I'm only looking for this part here, so the right hand, I guess, of this log. And I'm going to loop through those arrays, and let's do an every. Let's do an every for let's call them y values, and they will be let's check now that unique values is going to be a new set of the y values, and then let array, let's do return unique values dot array dot from unique values dot length is the same as y values dot length. So let me see if I'm doing it right. So object values for this object, what we're getting is an array of arrays, basically. We're getting an array of these, and then walking down that array to see if everyone have the same length when I remove the duplicates, and then create a new array from that. And if that was the exact same length of the original, then we have a truthy value here. We have a true, basically. And if this works at all, then we should get a, oh, hold on. I need the opposite of this. Okay, I think. New set is not defined. Oh. Oh, what did I do wrong? Oh, here. All right. So it's the opposite because it's every. So what we need is if this returns false, then not every, right? And if not every value in that array, so if not every, here, where's my log? Oh, I removed it. What I'm trying to say is that this didn't have any repeated value, right? So this part here is true for every single one of them, but then I'm going to need to know for that and this and this and this and this. So that way I know that the opposite of that will tell me if I actually crossed more than once. I don't know if that makes sense, but let's just give it a shot. Okay, so I'm going to test with the other values that I basically copied from the ones that weren't working for me, and they seem to work. Passed one. Wait, I didn't want to pass only one test. I need all of them. Or is it passing all of them? All right, let's just attempt the solution. All right, so we passed. And I guess this is actually more efficient than the solution that we had before, which was creating an array of all the strings and then looking for the repetition. Not manually, because I was doing the same kind of technique where I wanted to, let's remove this part here. And this one. Or let's say, given the instructions there, then we would have this kind of array, our map of things. And then we won't be needing this here. And then J is okay to be there. Let's see, we update J because we're trying to move forward one movement at a time, right? So that's what we're doing here. We're using J as an helper for going from up, right, down, left, and then back to up, right? So we're using J for that. And this is going to be our kind of dictionary of X values. Okay, I think the names make sense. So we're going to leave it at that. And let's probably add a comment here. So removing the duplicates, and then if the amount of unique values is the same as original, we didn't cross a coordinate more than once, right? If all comparisons return true, means the arrays have the same length, unique versus original. And then so we need to negate, is that what you call it? For the expected result, something like that. I hope I can I can revisit this code and say, oh, I know what I did. So I'm adding some comments in there. All right. So I'm looking forward for the for the solutions from other people. So I think I'm kind of excited that it actually worked and that I made it a little bit more efficient, just so much that the run actually passed. So let's give it a shot now. All right, so let's see. All right, it was gonna be easier than that, maybe. All right. Okay, we are walking down the array of instructions and determining whether some of the elements if our index is beyond 2. Okay, so more than 3 instructions. Yeah, this will break quickly, because if you had only, well, the constraint said that you had more than 3 instructions. So this will prevent the loop from going through, because at this point the robot wouldn't have crossed the same point at all, right? Because you would be just going upward and then right, and then it wouldn't ever cross. I think that's what's happening here. This is what I understand. Okay, and then for the length is more. Okay, so this was analyzing the kind of the math aspect of it, I guess. So if you went beyond the index at which you are right now, then you crossed. Something like that. Yeah, this is super terse. I don't even know if I'm understanding it right. Upward spiral. Yeah, there's a constraint about that. Okay, so they did take into consideration the context of the problem, and they knew that there was a kind of movement that was not ever going to happen. So they actually went with the solution. That's interesting. And here's my solution. This is the third one. And yeah, this is what we just went through. So these are more elaborate solutions than the first couple, as you can tell. I don't know how they rank them here. Could it be like the processing time? I don't know. We both have like zeros, but then mine is ranked a little bit. Oh, it might be just the might be just the alphabetical order. Yeah, that could be it. Interesting. Okay, I'm not going to spend some much more time in here, because yeah, this problem was in the back of my head for a few days now, and I actually thought about a little bit about this while I was driving. So being in traffic helps sometimes, I guess. In any case, thanks a lot for watching. Hope you can see the previous video when I'm trying to do it in a different way. It's basically the same basic or same algorithm here for walking down the instructions. I'm just reusing that in order to create a different data structure that will handle how my data is recorded, I guess, for me to analyze it later on with this. We can probably do something different, a little bit more interesting for the analyzing part of the situation here, but that's okay. My main goal was to complete it and actually share with you an algorithm that solves the kata. So we're good. That's all I needed. Thanks a lot. Catch you later. Bye.